Morning, ladies and gentlemen, and welcome to this morning's BIM presentation. My name is John Bennett from Daytech in Ireland. We're the distributor for all of Autodesk products on the island of Ireland. And with me today is Gerard O'Sullivan, who's going to be taking us through the more entertaining part of today's presentation, which is the live presentation. So my agenda for this morning is, first of all, I'm going to relook at defining BIM. I know this has been discussed a few times at the previous meetings, but I'm going to focus on what's the actual difference between CAD and BIM. We're also going to look at why should companies be investing and implementing in BIM right now, and also what might be keeping you up at night. A friend of mine, I met him last week, he's an architect, and he said he's sleeping like a baby at the moment. He wakes 3 times a night bawling his eyes out. So we might want to see why that is so. We'll also have a look at why Autodesk, and also the conclusion on what this could mean to your businesses. So defining BIM. CAD has been around for many decades now, and in the 80s, architects and engineers realised that they could take advantage of new computing technology to take care of the manual, tedious task of drafting. So going from the drawing board to a digital world. On this basis, we ran into some, and of course this was mainly based on the design documentation area. That's where CAD focused on. So one of the problems with this is that CAD traditionally works with lines, arcs and circles, and maybe some objects. Of course, various disciplines, they had their own file formats, their own standards, their own layering systems. And when we needed to transfer information from one discipline to another discipline, there was often huge loss of data. The next biggest issue that traditional CAD systems had was that there was a huge multi-coordination issue, which was a huge tedious task when a drawing needed to be changed, because all the other disciplines had to update every single drawing and ensure that they were accurate. But of course, this system is hugely open to errors. So with BIM, the entire concept of BIM starts from the essential physical model and considers the question of how physical components such as architectural components, civil components, structural components, site, interior design, and even the context of the building, how that information can be represented both geometrically, but also can be used as information throughout the entire building project lifecycle. So BIM is all about having an integrated process that helps coordinate everyone in the project and understands the project's key physical and also the functional characteristics well before the building is built. This coordinated, consistent information about a building enables engineers, contractors, civil engineers and owners to understand what their design will look like, and more important, how will it perform. And I think that's key to BIM, understanding the performance of a building. With BIM, the intelligent information of the building helps that process along the way. The coordination, the improved accuracy, the ability to make more informed decisions earlier in the process is key to this. For example, it allows an architect to convey their design intent to their clients very, very easily, but also it allows for predictable outcomes and reducing waste. Also, using the building information model, we can create our analysis earlier on in the project. So when we look at the 3 major benefits that BIM brings, it's all about being able to design innovatively and conducting our analysis early in the project. The second thing is about better visualization and optimization of real-world appearance, but also about performance and costs, something that we can't do with traditional CAD. And of course, the ability to document more accurately and more effectively. So this is just a quick slide from Patrick McLeamy, the CEO of HOK, and he has submitted this to the Construction User Roundtable. And his idea is that, first of all, when we look at the blue line on the graph, this is a typical project. And as we progress from preliminary design through to construction documentation and finally onto construction, it's clear that the ability to impact costs and functional capabilities decline. Inversely, the cost of any changes as we move through this process get more and more expensive as we go closer to the construction phase. And this is where traditional CAD sits, right in the middle of construction documentation. Not a huge amount being done in the preliminary design or schematic design stage, and even less being done after the construction documentation phase. With BIM, we need to work collaboratively, bringing every party or stakeholder involved in the project together earlier in the system so that we can ensure that all the clear goals are set, people understand what their roles are, and it allows us to spend more time in better decision making at the design cycle stage. With this process and collaboration based around building modelling information, the construction documentation now becomes a byproduct of our design efforts. So why should we be looking at implementing BIM now? We're all very aware of the economic situation that we're in, but also that there are fewer projects available out there. With the fewer projects, if you do happen to win those projects, the client normally dictates that they want to have the project to be completed either faster or indeed with less funding. Contractual changes, the relationships between clients and contractors and architects, this is evolving and changing all the time. BIM actually helps to sometimes solidify these relationships. All of our businesses have changed and we're now working on a global scale, which means that design teams need to work more effectively with people on a global basis. We need to make sure that the technology is there to support their efforts. And finally, there are now dozens of mandates that force builders, architects and engineers and owners to publish, know and understand the environmental impact that their creations are going to have. All of this does need a return on investment, and never before has return on investment been so important. These are the results of Stanford University Center for Integrated Facilities Engineering. They conducted a study based on 32 major projects using BIM. The results are absolutely outstanding. When we see a 40% elimination of unbudgeted change, coupled with an 80% reduction time in taking to generate the cost estimate, and when that cost estimate is within 3% accuracy. We can also see that clash detection, which is used really earlier on in the project, can actually have a savings of up to 10%, and overall a 7% reduction in project time. So what might be keeping people up at night time? For a CEO or principal, it's all about winning new business, diversifying the business, and getting those projects completed. For an IT or BIM manager, it's about understanding the resources that that organisation has and making them more effective and as efficient as possible. And for building owners, it's ensuring that the project programme is on time and that they end up with an asset that's both durable and sustainable for the future. With BIM, this is going to allow us to eliminate inefficiencies within businesses. It'll also allow BIM managers to ensure that they're producing documentation that's accurate, consistent, and in a timely manner. And of course, for building owners, imagine them being able to understand the performance of their building and generate those reports well before a machine arrives on site. For individuals within a company, architects, they need to get the job done accurately, professionally, and convey their design intent in the best format possible so all stakeholders involved understand what they're planning to do. For structural engineers, they need to ensure that they can actually keep this building standing up, and if an architect decides to make a change, that they're updated straight away and they can make the necessary changes. For MEP engineers, it's about understanding the performance of the building and putting in the systems that make these buildings as efficient as possible. For building contractors, building it within the original estimate and ensuring that the scheduling is all done on time. With BIM, it's going to help the architect to produce unique ideas, clearly communicate and anticipate how their designs are going to work in the real world. For structural engineers, it's about using the single model that the architect created, doing their stick analysis and getting that output as accurately and efficiently as possible. And for an MEP engineer, being able to predict the outputs of the building before it's built. And for the construction manager, BIM is going to help them to make better estimates earlier and actually resolve any clashes. So the clash detection is done in the digital model as opposed to waiting for something to happen on site. Really quickly, Autodesk divide their BIM strategy into various components. So for architects and designers, it's all about ending up with one single model that comes from the conceptual side, of which is all based on form and shape. And whether that's using an Autodesk product or Google SketchUp, you know, we can do all our creativity in that section, but we need to have that information to be as valuable as possible in our model. This is also coupled with the analysis and the visualization side, so that we can predict how our building is going to perform, but also generate all the marketing material, get the client buy-in also. Some of the generic outputs that we need is that we need a model that can actually easily translate into any other disciplines such as structure, mechanical engineering and plumbing, and from that also generate every construction document that is required, whether this is done on the fly or not, but this needs to be accurate to the original model. But being able to generate the customized fabrication, especially with so many unique buildings being built, everything's one-off at this stage, but being able to generate those fabrication drawings as required. Very similar situation to MEP. How this works is that the MEP engineer will receive a building from an architect, and from this they can quickly understand the area that they're dealing with and do their energy analysis as required. So they can do some real fundamental testing of their building before they do any design work. Again, they need to be able to generate all of their construction documents effectively, efficiently and accurately. Again, they also have the option to generate their fabrication drawings directly from the model. Getting the idea of this now, with structural engineering, it's the same thing. Either an engineer or an architect provides the main model, so it's a multidisciplinary model. The structural engineer can straight away create their stick analysis and understand the components in the building. From that, once the analysis is complete, they're happy with it, they can create all their construction documentation and once again fabrication drawings. The whole point of showing the 3Ds is just to show you the inputs and the outputs for BIM for construction. So on the input side, we've got all the structural information, architectural, MEP and civil. This will end up giving us a multidisciplinary model. And of course, the main outputs in the multidisciplinary model are all of our construction documents that are absolutely accurate and the visualization that we need for various stakeholders buy-in and also for marketing materials. But also, on top of that, we can get all our quantification, scheduling, 4D sequencing, and of course our clash detection. So these are all byproducts from the work that we've done already. And we can leverage this by sharing it with the extended team, for all our scheduling, building contractors, etc. So why would we be looking at Autodesk? And I think we're already behind time, so I'll keep this as fast as possible. Autodesk have a huge range of products that completely encompass the BIM workflow. The main portfolio is based on 4 pillars, which is Autodesk Civil 3D for civil engineering, Revit Architecture, Revit Structure, and Revit MEP. But these are also supported by individual products for specialized areas, such as Autodesk Ecotech for doing very quick, simple analysis of your energy in the building. Also 3ds Max Design to create your photorealistic renders for marketing, and of course QTO for your quantity takeoff. And there's a huge range of products there as well. Finally, my conclusion, BIM or Revit or Autodesk, it's not all about building walls, it's about building relationships and communications with everyone involved in the project. So with that, I'll pass you over to, sorry, there is more information on the autodesk.com/BIM website, white papers, return on investment, studies, and a huge range of information. So I'll just pass you off to Ger. Thank you very much for your time.